Good morning, everyone. That was quick. I'm Shon Richey with Alabama Power Company, and I want to talk to you a little bit today about a research project that we have going on in the Birmingham area. But before that, I want to tell you a little bit about who we are as a company. Alabama Power Company is one of many of the operating companies under the Southern Company of Baylor. We have 8 electric and natural gas utilities across the southeast, and approximately 30,000 employees with about 9 million utility customers. So we've got quite an expansive footprint, as you can see by the dots, where a lot of things to the west come into our renewables portfolio. So Smart Neighborhood by Alabama Power, our objective was to design and build a first of its kind, truly living laboratory to help us as a company prepare what the future grid needs may be for our customers, and to understand our customers' expectations a little bit better. So the scope of this project was distributed energy resources, use case optimizing cost, reliability, environmental impact with community scale microgrid. Also, we wanted to demonstrate 62 high-performance homes with connected home technologies. And as we saw earlier, this whole connected home world is becoming more and more of a thing. And so how do all these things kind of incorporate together, and how are customers using energy today, how our customers want to utilize energy down the road? And the homes were built with kind of a 20-year outlook in mind, where codes would be 20 years from now in the state of Alabama from an energy perspective. You couple that with connected devices, and it really changes the landscape of how customers are utilizing energy across their homes. We also wanted to demonstrate building to grid interaction. How does the building talk to the grid? What are the resources out there, and what are the impacts of that? At the end of the day, how do we better serve our customers from the learning and findings from this type of project? So this is a 2-year research project. These homes, of the 62 homes, they sold out really quickly in about 6 months. The build out was about 11 months. So all these homes are occupied at this point in time. And we're starting to get the data back from these homes. So as you can see in this overview slide, the neighborhood of 62 homes is called Reynolds Landing. About a half mile as the crow flies through the woods, we've got a microgrid that's about 1 megawatt of generation storage capacity that is feeding this neighborhood. So all the energy produced there feeds the neighborhood, feeds through the neighborhood, and then back onto the grid. These homes are high-density housing for our area, very, very narrow lot lines. So we had a lot of homes on a small parcel of land. We did not change any of the architecture of these homes. We basically fit the standard builder's architecture into our business plan or business model to make them high performance and some of the integration going forward. So a project like this could not be completed, especially in the time frame that we did, could not be pulled together, would not be successful without some great partners. And one of our partners that we're going to be talking about here in just a few minutes is REAM, who provide our heat pump water heaters for the project, and one of our research partners on the project. So 3 main tenets for the homes on this project. We wanted the homes to be comfortable, number one. We wanted them to be convenient, and then ultimately we wanted them to be connected. So connected via phone, app, or voice automated, but also connected to the grid. And what does that look like? So this is a snapshot of some of the different components that make up these homes, make up the efficiency component. Those that are familiar with the HERS index, these homes had an average HERS index of around a HERS 45, where state code in Alabama is around a HERS 70. So quite a bit more efficient than what the baseline minimum is, which those of you that know the Southeast, a lot of times we're kind of slow to adopt new technologies, new trends, and new codes. So this is quite efficient for our area. Utilizing the variable capacity heat pumps, heat pump water heater, a very advanced building envelope, we were able to achieve those energy efficiency results that we were looking for. You couple that with smart connected technologies and circuit level data collection in each one of the homes, and not only just circuit level data that we're collecting, but also water flows, water temperatures, and things of that nature, relative humidity, and different things. So a lot of data that we're pulling back in. So from the water heating aspect, I mentioned that our project partner on this was REAM. We utilized their 80-gallon heat pump water heater. This water heater was outfitted with a mixing valve, So we're able to store more energy in that tank. So we've got a thermal battery. We're using the houses as thermal storage and the water heaters as thermal batteries as well. So, this project worked out very well for this project. So part of the research components and the research objectives was to look at the high performance homes, distributed energy resources with the microgrid. And that microgrid is comprised of solar generation, natural gas generation, and battery storage, all of which can sustain the house for a certain amount of time, sustain the entire community for a certain amount of time in the event of an islanding type situation. Looking at building to grid integration as well as the connected home devices. So to talk a little bit about the data collection, we've got 62 homeowners. Each one of these homes are filled with multiple people. And prior to us feeling comfortable with these customers moving into these homes, we did a lot of training on the front end to let them understand the data that we're going to be collecting, how it's going to be anonymized, and how it's going to be aggregated to where, as a utility perspective, we can use it. For industry perspective, you can use it. And we don't know that house number 623 is using X amount of water or X amount of energy. So keeping the information as private as possible, but also aggregating it to where we can understand exactly what's going on at any point in time. So in this dashboard, we utilized a system called SiteSage to do our data collection. And in this dashboard, our customers also have access to every circuit in their home to understand how this energy is being used, as well as our water flows. So they start seeing how their behaviors affect energy consumption, water consumption, and different things. So to talk a little bit about the efficiency and the benefits of the efficiency from this project, we talked about they've got a HERS index of approximately 45, or an average of 45. So our kilowatt hour savings on this project versus a baseline neighborhood just right down the road, we had about 44% kilowatt hour savings on this project. We saw a pretty good peak reduction, about a 16% peak reduction in the summer. And now we're a winter peaking utility. So winter peaks are one of the things that we're really trying to look at, capitalize on. How do we reduce those winter peaks to get closer to their summer peaks? So we were able to reduce winter peaks by about 34.5% in general, utilizing the building to grid integration on the water heating and on the HVAC controls. So fairly significant savings there, or reductions. One of the things you'll notice, this is the energy information, the U.S. energy information chart on the right, or the graph on the right, and water heating is at 14% on 2015 statistics. In this particular neighborhood, we're hitting around 8.5% of the pie of energy in that home for water heating. Now, one of the reasons for this, and this number could be higher, could be lower, is because we're actually controlling the water heaters and controlling the loads from behind the water heater, so to speak. So our customers, we're adjusting modes, we're adjusting the time that mode changes, and we're adjusting temperature. And all these heaters do have a mixing valve, so the delivered water temperature is consistent to the customer. So if you look at the smart neighborhood, the heat pump water heater graph versus our line versus what an electric model would be, you can see the difference between the area of the two curves. That's our savings and our load shape impacts. Now, that electric water heater model, if you start looking at, when you explode that view, the model is pretty consistent with actual usage. On the left-hand side is water heating. On the right-hand side is HVAC load. What you'll notice on the right-hand side, modeled HVAC data, they're very close, but the modeled HVAC data on the right-hand side is a standard heat pump, not a high SEER variable capacity heat pump. So there's in some of the models that we as a utility are using, we've noted that the models are not lining up exactly what we're measuring. So that's something for us to take back, something that we've learned, that sometimes our models, models aren't exactly right. We've got one of our researchers, he always says models are great. He said some models are useful, some are not. Some of the models are not useful. But there are some good information, good data components out of those models that we can use. So some of the transactive controls that we have in this particular project, if you'll notice on the screen, and on this screen as well, we've got two different components. We've got seismic and Voltron. Both of those are revolutionary kind of controls for this building to grid integration and the distributed energy resources, managing those distributed energy resources. So that was developed by Oak Ridge National Labs, and they're actually controlling how energy is fed to the neighborhood, as well as how the water heaters and heat pumps are operating through their control. So based on pricing signals, based on demand, based on need, they can actually adjust those controls and those algorithms to adjust the units as needed. So to get into a little bit of the data that we've gotten so far, and this was with 53 homes reporting. Right now on the water heaters, we had 19, about 36% that were in the energy saver mode. 30 of the water heaters were in heat pump mode only, so about 57% that were in heat pump. Of that, we had 7% of the customers who adjusted the mode throughout July. And then the average water heating set point was 130 degrees. Now, one thing I'll note, and I was talking to Gary about this earlier, is we started pulling the data as to the actual gallons of hot water used on each one of these customers. And the average number of occupants is 2.4 occupants per household. I gave a presentation a couple of weeks ago and it was at 2.25, but the latest data shows us that it's at 2.4 now. And with that, we were at 37 gallons of hot water usage a day. So you look at what some of the averages were back several years ago. That's quite a reduction in hot water usage for an average family, average size family. So one of the other things that we're doing, part of the data collection, is we've actually got temperature sensors in the garage where these water heaters are located. We're measuring incoming water temperature, outgoing water temperature, space temperatures inside, plus power. So we're able to get real-time coefficients of performance for these heaters that are installed. One of the things that we saw, now this data is a little bit skewed, so take that into account when I tell you that, but one of the things that we saw of the lab-tested COP of approximately 3.5 for these heaters, we had less than 10 homes seeing a COP over 3.0. Now, here's where this connected home technologies kind of comes into play. Of that, we had 15% of the data where the water heaters were not reporting back, and it's nothing to do with the product. It was to do with the internet connection. We were having some internet connectivity issues at that point in time. So that number could be skewed just a little bit to the higher end when you have that other 15% reporting. So one of the things that we were able to accomplish, and when I say we, this is a collaborative effort between Alabama Power, Southern Company, Oak Ridge National Labs, and EPRI, was the avoided peak demand. And this is demonstrated where we were able to preheat the water prior to a peak demand time and avoid that peak demand. So you can see this was successful in testing and with very little water temperature differential. We really didn't drop much below 120 degrees while doing this. In that 115 range, which is still in that safe range. So that's all I have. I look forward to questions and comments afterwards. Be glad to go into this project in much more detail after this presentation is over. And thank you for your time.